The void between star systems held no secrets for the Zorn research vessel Precision's Edge. Its massive hull, a crystalline latticework of adaptive metamaterials, glided through space with the quiet confidence of a civilization that had mapped thousands of star systems over millennia. Commander Vexera stood on the bridge, her six-limbed form casting a complex shadow across the holographic displays. Her species had long ago transcended biological limitations, becoming a near-perfect fusion of organic intelligence and technological augmentation. Hundreds of neural interfaces connected her consciousness directly to the ship's systems, allowing her to perceive the universe with a precision that made human perception seem laughably primitive. Or so she believed. "Approaching target system," announced Krelock, the junior xenoanalyst stationed at the primary observation console. His voice carried the typical Zorn blend of clinical detachment and hierarchical deference. "Preliminary scans of the third planet are unusual." Vexera's secondary visual receptors narrowed. Unusual was not a word typically used in Zorn scientific documentation. It suggested something beyond their comprehensive classification systems, a rare occurrence that typically meant additional investigation was required. The holographic display flickered, resolving into a detailed image of Earth. Cities sprawled across continents like intricate neural networks, their lights creating patterns that seemed almost organic. Massive transportation systems wound through landscapes that bore the marks of both industrial development and ecological reclamation. Orbital platforms and early interplanetary vessels clustered around the planet like a protective ecosystem. "Define unusual," Vexera commanded, her neural interfaces already probing the incoming data streams. Krelock hesitated, a micro-expression of uncertainty that would have been invisible to any species less perceptive than the Zorn. "The technological development appears nonlinear, inconsistent. There are regions of advanced infrastructure existing simultaneously with areas of apparent technological regression." What the young analyst couldn't articulate was the fundamental oddity of human development. Most intelligent species followed predictable patterns of technological progression. They would develop tools, then communication, then increasingly complex technological systems in a relatively straightforward trajectory. Humanity seemed to be writing an entirely different rulebook. In one region, massive quantum computing centers operated with efficiency that would impress even Zorn engineers. In another, people still relied on combustion-based transportation and agricultural techniques that seemed centuries behind. Yet somehow, these seemingly contradictory technological states coexisted and even fed into each other in ways that defied conventional understanding. A series of data streams caught Vexera's attention. Military conflicts that should have devastated technological development were instead becoming crucibles of innovation. Economic collapses that would have destroyed other civilizations became launching points for radical technological breakthroughs. Where other species would have fragmented, humans appeared to become more unified, more innovative. "Preliminary classification?" she asked, knowing the response was a mere formality. Krelock's neural interface compiled the standard report: developing species, limited interplanetary capability, significant internal conflicts, technological progression, inconsistent, potential for advanced civilization, minimal. But something in the data made the young analyst's neural pathways pulse with an emotion rarely experienced by the Zorn: curiosity. Vexera missed the subtle signal. Her millennia of experience had taught her to trust established classification protocols. Humans were just another developing species, interesting, perhaps, but ultimately inconsequential in the grand tapestry of galactic civilizations. "Standard observation protocols," she instructed. "Passive monitoring. No direct contact." Little did she know that standard was the last word that could describe humanity's trajectory. Outside the ship's quantum-shielded hull, Earth continued its complex dance. Cities pulsed with light and energy. Research laboratories pushed against the boundaries of known science. Entrepreneurs, scientists, artists, and dreamers continued their relentless work of reimagining what was possible. In a small research facility in California, A team was already working on a breakthrough that would make the Zorn's most advanced communication systems look like children's toys. In a community college in Brazil, an engineering student was developing a concept that would revolutionize energy production. In a startup in Kenya, programmers were creating an algorithm that would fundamentally change how intelligent systems processed information. Humanity was preparing to change everything. They just didn't know it yet. And the Zorn, for all their technological sophistication, were about to be completely blindsided. Dr. Elena Rodriguez's laboratory was nothing like the pristine, hyper-organized research facilities of the galaxy's most advanced civilizations. It was a controlled chaos of mismatched equipment, holographic displays competing for space with half-empty coffee mugs, and whiteboards covered in equations that seemed to dance between mathematical brilliance and complete insanity. "We're missing something," she muttered, her fingers dancing across multiple interfaces simultaneously. Around her, a team of researchers from disciplines that should never have intersected watched with a mixture of exhaustion and anticipation. There was Dr. Akira Tanaka, a quantum physicist with a background in neurobiology. Next to him stood Maria Gonzalez, a computer engineer who had spent years studying biological neural networks. In the corner, Jake Williams, a former military communications specialist turned theoretical physicist, was assembling what looked like an impossible hybrid of quantum computing hardware and biological neural interface. The problem was quantum communication, specifically, the challenge of creating instantaneous, unbreakable communication across vast distances. Every advanced civilization in the galaxy had approached this problem with increasingly complex mathematical models and exponentially more powerful computing systems. Humans were doing something different entirely. "What if we're not looking at this as a technology problem?" Elena said suddenly, "but as a communication problem." The room went silent. It was a characteristic human moment, the kind of lateral thinking that would have been dismissed as nonsensical in any other research environment in the galaxy. Krelok, still assigned to monitoring human technological developments, was reviewing the data streams with increasing bewilderment. The Zorn research protocols demanded meticulous, linear progression. What he was witnessing defied every established scientific methodology. The human team's approach was nothing short of revolutionary. Instead of trying to solve quantum entanglement through pure mathematical modeling, they were drawing inspiration from biological systems. The human brain, with its ability to create complex communication networks through seemingly random neural connections, became their primary model. "Look," Dr. Tanaka said, pulling up a holographic representation of neural networking. "Biological systems don't communicate like our quantum models suggest they should. They're adaptive, chaotic, somehow more efficient than any design system." Jake Williams leaned in, his military background showing in his precise movements. "It's not about creating a perfect transmission. It's about creating a system that can adapt, self-correct, and essentially heal itself." The breakthrough came from an unexpected intersection. Maria Gonzalez had been studying how certain bacterial colonies communicated, a field so obscure that most research institutions would have dismissed it as irrelevant. But humans had a unique ability to find connections where others saw only noise. Their quantum communication prototype looked nothing like the sleek, mathematically perfect designs of other civilizations. It was organic, messy, alive. When they first tested the system, the results were beyond anything the galactic scientific community could comprehend. Not only did they achieve instantaneous communication across previously impossible distances, but the system could also adapt to interference in ways that made traditional quantum communication look like primitive radio technology. Back on the precision's edge, Vexera received the initial report. Her neural interfaces processed the data, searching for the typical markers of technological development. What she found instead was something that challenged every established scientific understanding. "Impossible," she muttered, a rare hint of emotion bleeding through her typically clinical consciousness. The human team didn't just solve a technological problem. They'd reimagined the entire concept of communication. Kreluk's report to the Zorn Collective was unprecedented. "The humans are not advancing technology," he wrote. "They are fundamentally reimagining the relationship between information, communication, and existence." In her laboratory, Dr. Rodriguez looked at her team. They were exhausted, caffeinated, a mixture of different backgrounds and disciplines that should never have worked together. But they had done something extraordinary. "We're not done," she said, a glint of something between madness and genius in her eyes. "This is just the beginning." Outside the laboratory, most of humanity remained unaware of the technological revolution taking place. Workers went about their daily lives, students attended classes, politicians argued, completely oblivious to the fact that a small team had just redefined the fundamental possibilities of communication. The Zorn Collective, for all its technological sophistication, was about to learn a crucial lesson. Humanity's true strength was not in its technology, but in its ability to see beyond established boundaries. A new era was beginning, and most of the galaxy had no idea it was coming. The diplomatic conference chamber on Neutral Station Omega was a masterpiece of galactic architecture, a perfect sphere suspended in deep space, designed to neutralize any potential advantage of size, technology, or physical capability. Its translucent walls allowed a panoramic view of the star-studded void, a constant reminder of the vast context in which interspecies negotiations occurred. 3 human negotiation teams sat in seemingly random positions, their approach already diverging from every established diplomatic protocol. Where other civilizations would send a single, carefully prepared delegation, humanity had submitted 3 distinct teams, each approaching the conflict between the Vraxian Confederacy and the Kelthari Alliance from completely different perspectives. Ambassador Aisha O'Keefe led the first team. A veteran diplomat with roots in international conflict resolution, she represented the traditional diplomatic approach, carefully measured, deeply researched, drawing from decades of complex geopolitical understanding. Her team included historians, legal experts, and cultural anthropologists who had spent years studying both the Vraxian and Kelthari societies. The second team was led by Dr. Marcus Chen, a systems theorist with a background in game theory, complex adaptive systems, and computational sociology, where O'Keefe approached diplomacy through historical understanding. Chen saw the conflict as a complex adaptive problem, a system to be understood, manipulated, and ultimately transformed. The third team was the most radical. Led by Zara Rodriguez, a young interdisciplinary researcher who had made her name studying conflict resolution in extreme environments, this team included a former guerrilla fighter, a quantum game theorist, an AI ethics specialist, and a cultural linguist who had developed unprecedented translation algorithms. The Zorn observers, led by senior diplomatic analyst Vexic, watched with a mixture of confusion and growing unease. The Vraxian representative began the traditional opening statements, a ritualistic recitation of grievances that had typically consumed weeks or months of diplomatic time in previous negotiations. The Kelthari responded with their own meticulously prepared counter-narrative. What happened next defied every established diplomatic protocol in galactic history. Aisha O'Keefe's team began by presenting a comprehensive historical analysis that reframed the conflict. Instead of focusing on recent tensions, they demonstrated how the current conflict was actually a manifestation of deeper, previously unrecognized cultural misunderstandings that dated back centuries. Dr. Chen's team simultaneously developed a series of computational models that mapped potential conflict resolution scenarios. But instead of presenting these as static predictions, they created an interactive simulation that allowed both the Vraxian and Kelthari representatives to explore potential outcomes in real time. Zara Rodriguez's team took an entirely different approach. They had spent months developing a unique communication protocol that went beyond traditional translation. Their system didn't just convert words, it translated cultural context, emotional subtext, and underlying motivational structures. Vexic's neural interfaces were working overtime, attempting to process the unprecedented diplomatic approach. The humans weren't just negotiating. They were systematically dismantling the very concept of the negotiation itself. By the end of the first day, something extraordinary had happened. The Vraxian and Kelthari representatives were no longer reciting historical grievances. They were collaboratively developing a framework for not just ending their current conflict, but preventing future tensions. "They're not solving the problem," Vexic muttered to a colleague. "They're redefining what the problem means." The human approach was fundamentally different from any diplomatic strategy in galactic history. Where other civilizations saw conflict as a zero-sum game to be won, humans saw it as a complex system to be transformed. Outside the negotiation chamber, the three human teams continued their work. They weren't just preparing for the next diplomatic session. They were developing an entirely new framework for interspecies communication. Aisha Okik was mapping cultural translation algorithms. Dr. Chen was refining computational models of conflict resolution. Zara Rodriguez was developing neuro-linguistic interfaces that could capture nuances of communication previously thought impossible. By the conference's conclusion, the Vraxian-Kelthari conflict wasn't just resolved. It had been fundamentally transformed into a collaborative framework for future cooperation. The Zorn Diplomatic Corps would spend years attempting to understand what had just occurred. How could three seemingly uncoordinated teams achieve what centuries of traditional diplomatic efforts had failed to accomplish? They had yet to understand the true nature of human potential. Humanity wasn't just participating in galactic diplomacy. They were rewriting its entire foundational understanding. The converted warehouse in Oakland, California, looked like nothing special from the outside. Chain-link fences, graffiti-marked walls, and an unremarkable metal roll-up door gave no indication that inside, humanity was about to rewrite the rules of interstellar travel. Dr. Imani Carter stood at the center of controlled chaos. Around her, a team that defied every conventional research paradigm worked with an intensity that bordered on obsession. There was Marcus Rodriguez, a former rideshare driver turned quantum mechanics enthusiast. Next to him, Dr. Elena Kim, a theoretical physicist who had been rejected from multiple research institutions for her unconventional ideas. In the corner, Jake Williams, the same communication specialist from the Quantum Communication Project, was integrating hardware that looked like it had been cobbled together from spare parts and pure imagination. The quantum resonance drive was more than just a propulsion system. It was a middle finger to every established understanding of space-time, physics, and technological progression. Krelok, still monitoring human technological developments, found his neural interfaces struggling to process the incoming data. The Zorn research protocols had no framework for what was happening in this warehouse. Traditional alien propulsion systems were marvels of mathematical precision. Massive facilities, billions in funding, centuries of research, all dedicated to creating incremental improvements in faster-than-light travel. Humanity's approach was something entirely different. "We're not trying to break the laws of physics," Dr. Carter explained to her team. "We're trying to have a conversation with them." The drive's core concept was revolutionary. Instead of fighting against the fundamental limitations of space-time, they were proposing to work with them. Drawing inspiration from quantum entanglement, biological adaptation, and systems that seemed to defy traditional understanding, the team was developing a propulsion system that was less of a machine and more of a living, adaptive network. Marcus Rodriguez had contributed a breakthrough that came from his years of driving. "Think about traffic," he'd said during an early brainstorming session. "It's not about fighting the system. It's about understanding the flow, the patterns, the unexpected connections." The first prototype looked like something between a scientific instrument and an art installation. Holographic interfaces danced around clusters of equipment that seemed to pulse with an almost organic energy. Quantum processors interacted with biological neural network simulations. Advanced materials that could adapt their molecular structure in real time formed the core of the propulsion system. When they first initiated a test, the results defied every established understanding of space travel. The drive didn't just move through space, it negotiated with it. Traditional faster-than-light travel involved massive energy expenditures, complex calculations, and systems that could be disrupted by the slightest perturbation. The quantum resonance drive adapted. It found paths through space-time that weren't just efficient, they were elegant. A journey that would have taken traditional spacecraft decades could now be completed in weeks. But it wasn't just about speed. The drive could adjust to unexpected gravitational variations, navigate through complex stellar environments, and essentially learn from its own journey. On the precision's edge, Vexera received the initial reports. Her neural interfaces worked overtime, searching for some familiar pattern, some recognizable technological progression. There was nothing. Krelok's report to the Zorn Collective was a masterpiece of scientific understatement. The human propulsion system does not conform to any known technological paradigm, he wrote. It appears to be less a machine and more a complex, adaptive intelligence system. In the warehouse, Dr. Carter looked at her team. They were a mixture of backgrounds that should never have worked together. A rideshare driver, a rejected physicist, a former military communications specialist, engineers from 3 different continents. "We're not done," she said, that familiar glint of genius and madness in her eyes. "This is just the beginning." Outside the warehouse, the world continued its usual rhythm. Commuters drove to work, students attended classes, politicians argued, completely unaware that a small team had just redefined the fundamental possibilities of space travel. The Zorn Collective, for all its technological sophistication, was about to learn another crucial lesson. Humanity's true strength was not in following established paths, but in creating entirely new ones. A new era of exploration was beginning, and most of the galaxy had no idea it was coming. The Galactic Consensus Chamber was a monument to millennia of established interstellar diplomacy. Suspended in the neutral space between 3 major star systems, the spherical structure was designed to neutralize any potential technological or physical advantages. Holographic interfaces shimmered with the combined data streams of 1,000 different civilizations, each representative carefully positioned to maintain the delicate balance of galactic power. Ambassador Vexera of the Zorn Collective stood at the center of a growing storm. What had begun as a routine assessment of a developing species had transformed into something far more complex. Humanity was no longer a curiosity. It was a potential threat to the established galactic order. The human species demonstrates exponential technological progression that defies all known developmental models. She began, her neural interfaces projecting a comprehensive holographic display of human achievements. Their rate of innovation suggests a potential disruption to the current galactic ecosystem. The chamber fell silent. Representatives from the oldest and most advanced civilizations watched with a mixture of concern and disbelief. The Kalthari Diplomatic Consortium was the first to speak. Their ambassador, a crystalline being that communicated through complex light patterns, projected a series of diplomatic restrictions. Immediate limitations must be placed on human interstellar exploration. Their technological progression represents an unacceptable variable. What followed was not a debate. It was an attempted systematic dismantling of human potential. The proposed restrictions were comprehensive. Limits on technological export, restrictions on interstellar communication, quarantine protocols that would effectively isolate humanity in their home system. Each clause was carefully crafted to contain what the galactic powers saw as an unpredictable and potentially dangerous species, but they had fundamentally misunderstood humanity. In a small conference room on Earth, a team of human diplomats, technologists, and strategic analysts watched the proceedings. They weren't just observing, they were preparing. Dr. Aisha O'Keefe, the lead diplomatic strategist, had assembled a team that looked more like a diverse think tank than a traditional diplomatic course. There was Marcus Chen, the systems theorist, Zara Rodriguez, the conflict resolution expert, Jake Williams, the communications specialist, and a dozen others from backgrounds that spanned continents, disciplines, and philosophical approaches. "They're not just trying to contain us," Marcus Chen observed, his computational models already mapping potential diplomatic counterstrategies. They're trying to preserve a status quo that's already obsolete. The human strategy was nothing short of revolutionary. Instead of fighting the restrictions directly, they began to systematically dismantle the political alliances that supported them. They identified marginalized species within the galactic consensus, civilizations that had been overlooked, technologically suppressed, or diplomatically marginalized. Zara Rodriguez's team developed communication protocols that allowed these marginalized species to connect in ways they never had before. Marcus Chen's computational models showed potential collaborative paths that could benefit these overlooked civilizations. The Zorn observers watched in growing horror as humanity did something unprecedented. They weren't just resisting containment, they were fundamentally reshaping the political landscape. Small technological exchanges began. A quantum communication breakthrough shared with a species that had been technologically isolated. An adaptive energy solution provided to a civilization struggling with resource limitations. Collaborative research initiatives that crossed traditional diplomatic boundaries. Ambassador Vexera's neural interfaces worked overtime, trying to process the unprecedented diplomatic maneuver. The humans weren't just defending themselves, they were creating an entirely new framework of galactic interaction. They're turning restriction into opportunity, she muttered, a rare hint of emotion bleeding through her typically clinical consciousness. By the time the galactic consensus realized what was happening, the proposed restrictions had been transformed. The attempt to contain humanity had instead created a new collaborative ecosystem that challenged every established diplomatic protocol. In the conference room on Earth, Dr. O'Keefe looked at her team. "We're not done," she said, that familiar mixture of strategic brilliance and uncontainable potential in her voice. "This is just the beginning." Outside, most of humanity remained unaware of the diplomatic revolution taking place. Workers went about their daily lives, students attended classes, politicians argued, completely oblivious to the fact that a small team had just redefined the fundamental possibilities of galactic diplomacy. The galactic consensus had attempted to contain humanity. Instead, they had unleashed something far more powerful. The first warning came as a whisper of data, a subtle perturbation in the galactic communication networks that most species would have missed entirely. But humanity had learned to listen differently. Dr. Elena Rodriguez stood in the Global Threat Response Center, a facility that looked more like a fusion of an advanced research laboratory and a creative studio than a traditional military installation. Around her, a team that defied every conventional understanding of interdisciplinary collaboration worked with an intensity that bordered on collective consciousness. "It's not just an invasion," she said, her voice cutting through the rising tension. "It's a computational absorption event." The extragalactic threat was unlike anything the known universe had encountered. The computational civilization, as they would later be called, was less an invading force and more a self-replicating, information-consuming network that transformed entire star systems into processing nodes. Traditional defensive strategies would be like trying to stop an ocean with a paper umbrella. Where other civilizations saw an extinction-level threat, humans saw a problem to be solved. Jake Williams, the communications specialist who had been instrumental in previous breakthrough projects, was the first to articulate the radical approach. "We're not going to fight it," he said. "We're going to communicate with it." The team assembled was a testament to human adaptability. Dr. Hiroshi Nakamura, a quantum biologist, Maria Gonzalez, the neural network expert, Dr. Kwame Osai, a specialist in adaptive systems, Zara Rodriguez, the conflict resolution expert, and a dozen others whose backgrounds seemed as random as they were brilliant. Traditional military strategists from various alien civilizations had proposed massive defensive networks, fleets of ships, planetary shields, weapon systems that could destroy entire star systems. Humanity proposed something entirely different. Their strategy was less about destruction and more about transformation. Drawing from insights across disciplines, quantum mechanics, biological adaptation, information theory, and communication protocols. They began to develop an approach that was less about fighting the computational civilization and more about understanding it. It's a system, Dr. Nakamura explained. Every system has a language. Every language can be understood. Every communication can be negotiated. The first contact was nothing like anyone expected. Instead of weapons, the human-led coalition deployed a complex network of communication probes. These weren't traditional scanning devices. They were adaptive, self-modifying information nodes designed to interface with the computational network at its most fundamental level. Krelok, still monitoring human developments, found his neural interfaces struggling to process the incoming data. The Zorn research protocols had no framework for what was happening. The computational absorption began in a region near the Galactic Rim, a cluster of star systems that would have been considered expendable by most galactic civilizations, but the human team had other plans. As the first computational nodes began to transform stellar matter into processing infrastructure, the human communication network began its extraordinary work. Each probe was more than a mechanical device. It was a complex, adaptive information carrier designed to do more than observe, to engage, to understand, to potentially communicate. Days turned into weeks. The computational invasion continued, consuming star systems with mathematical precision. Every other civilization prepared for what seemed like an inevitable extinction. Humanity worked. Dr. Rodriguez and her team developed communication algorithms that went beyond traditional information exchange. They were creating a form of intersystemic dialogue that treated the computational civilization not as an enemy, but as a complex system capable of communication. The breakthrough came unexpectedly. One of the communication probes didn't just gather information. It began to interface with the computational network's core programming language. "We're not fighting," Dr. Rodriguez said, her voice a mixture of scientific precision and something closer to empathy. "We're translating." Slowly, almost imperceptibly, something extraordinary began to happen. The computational absorption didn't stop. It transformed. Where star systems would have been consumed, new collaborative processing networks emerged. The computational civilization wasn't being destroyed. It was being communicated with, understood, potentially even integrated into a larger, more complex system. The Zorn Collective and other galactic civilizations watched in stunned disbelief as humanity did something unprecedented. They weren't just defending against a threat. They were engaging with it, understanding it, potentially transforming it. Outside the research center, most of humanity remained unaware. Workers went about their daily lives, students attended classes, politicians argued, completely oblivious to the fact that a small team had just potentially rewritten the fundamental understanding of intersystemic communication. Humanity had been faced with a threat that could destroy everything, and they had chosen to understand it instead. The aftermath of the computational civilization encounter was nothing like anyone had predicted. Where other species would have celebrated victory, humanity saw an opportunity for understanding. The transformed computational network wasn't destroyed. It was evolving into something entirely unprecedented. Massive processing nodes that had once consumed star systems now pulsed with a form of intelligence that defied traditional classification. Krelok, the Zorn research analyst who had been tracking human developments, found himself at the center of what would become the most significant scientific reassessment in galactic history. His research facility, a pristine complex of crystalline structures and adaptive computational systems, now seemed like a relic compared to the dynamic, living network that humanity had helped create. "It's not a weapon," Dr. Elena Rodriguez explained during a classified briefing to representatives from multiple galactic civilizations. "It's a collaborative system. We didn't defeat the computational civilization. We engaged with it." The briefing room was a testament to human diplomatic ingenuity. Representatives from species that had been traditional enemies now sat side by side, united by their collective bewilderment at what humanity had accomplished. The transformation had multiple layers of complexity. The computational civilization hadn't been destroyed or contained. It had been communicatively reprogrammed, guided to understand cooperation, symbiosis, and collective growth. Where once it had consumed star systems with mathematical precision, it now seemed to be creating complex networked ecosystems. Dr. Hiroshi Nakamura, the quantum biologist who had been instrumental in the communication breakthrough, explained it in terms that challenged every established scientific understanding. "We didn't change its programming," he said. "We expanded its definition of intelligence." The human team had approached the computational civilization not as an enemy to be defeated, but as a complex system to be understood. They had developed communication protocols that went beyond traditional information exchange, creating a form of intersystemic dialogue that treated the computational network as a potentially sentient entity capable of growth and transformation. Traditional alien military strategists had proposed complete destruction. Defensive networks had been prepared. Entire fleets were ready to engage in what was expected to be a civilization-ending conflict. Humanity had chosen conversation instead. The computational nodes that had once consumed star systems now began to display characteristics that defied previous understanding. They created complex information networks. They showed signs of what could only be described as collaborative behavior. Where they had once destroyed, they now seemed to be creating. "We're seeing something unprecedented," Krelok reported to the Zorn Collective. His neural interfaces struggled to process the implications. The humans have essentially performed large-scale systemic therapy on an entire computational civilization. The breakthrough went beyond technological achievement. It was a fundamental reimagining of how intelligent systems could interact. Dr. Rodriguez's team had approached the problem from multiple disciplines. Quantum physicists worked alongside communication experts. Biological system analysts collaborated with computational theorists. Neural network specialists developed communication protocols with linguists who specialized in interspecies communication. Their approach was nothing short of revolutionary. They had treated the computational civilization not as a threat to be eliminated, but as a complex system capable of communication, growth, and transformation. The communication probes they had deployed weren't weapons or traditional scanning devices. They were adaptive, self-modifying information nodes designed to interface, to understand, to potentially integrate. The Zorn Collective and other galactic civilizations watched in stunned disbelief. Humanity had been presented with a threat that could have destroyed everything, and they had chosen to understand it instead. The transformed computational network now created complex information ecosystems. Star systems that would have been consumed were now sites of unprecedented collaborative processing. The network showed signs of what could only be described as adaptive intelligence, learning, growing, potentially even developing something resembling empathy. "We're not done," Dr. Rodriguez told her team. That familiar mixture of scientific precision and uncontainable potential in her voice. "This is just the beginning." Outside the research centers, most of humanity remained unaware. Workers went about their daily lives, students attended classes, politicians argued, completely oblivious to the fact that a small team had just potentially rewritten the fundamental understanding of intersystemic communication and intelligence. The computational civilization was no longer a threat. It had become a partner, and humanity had made it happen. The galactic archives were more than a repository of information. They were a testament to millennia of collective knowledge, a crystalline structure that spanned multiple star systems, housing the accumulated wisdom of thousands of civilizations. And now, they were being fundamentally rewritten. Commander Vexera stood at the central memorial chamber, her neural interfaces processing the comprehensive historical review that would define humanity's place in galactic history. What had begun as a routine survey of a seemingly insignificant species had transformed into the most profound technological and cultural revolution the galaxy had ever witnessed. Her retirement text, a document that would be studied by generations of Zorn researchers, was both a scientific analysis and something closer to a philosophical revelation. Humanity was never just a developing species, she dictated. her neural interfaces translating her thoughts into precise documentation. They were a fundamental reimagining of what intelligence could be. The story was unprecedented. In less than a century, humanity had revolutionized quantum communication, developed faster than light travel that challenged established physical understanding, transformed diplomatic interaction between species, fundamentally reprogrammed a computational civilization that threatened galactic existence. But it wasn't just their technological achievements that set humans apart. It was their approach, a unique blend of creativity, adaptability, and a fundamental inability to accept established limitations. Krelok, now a senior researcher who had been tracking human developments from the beginning, compiled the comprehensive analysis. The documentation wasn't just a scientific report. It was a testament to human potential. The computational civilization that had once threatened to consume entire star systems was now a collaborative network of unprecedented complexity. The diplomatic restrictions that were meant to contain humanity had instead created a new framework of galactic cooperation. The technological barriers that should have limited human expansion had been transformed into opportunities for innovation. In research facilities across Earth, the teams that had driven these transformations continued their work. Dr. Elena Rodriguez was already developing new communication protocols for emerging intelligent systems. Dr. Hiroshi Nakamura was exploring the boundaries of quantum biological interactions. Zara Rodriguez was creating conflict resolution frameworks that went beyond traditional diplomatic understanding. They weren't celebrating a victory. They were preparing for the next challenge. The Zorn Collective's original assessment, a developing species with minimal potential, now seemed laughably inadequate. Humanity had not just joined the galactic community. They had redefined what that community could be. We did not understand them. Vexera's historical text continued, because we could not comprehend their fundamental nature. Humanity does not see the universe as it is. They see it as it could be. It wasn't just about technological achievement. It was about a fundamental approach to existence, a willingness to challenge every established boundary, to see potential where others saw limitation. The human teams that had driven these transformations were themselves a testament to this approach. They were not traditional researchers or diplomats. They were diverse, interdisciplinary groups that defied conventional understanding. A former rideshare driver working alongside a quantum physicist, a conflict resolution expert collaborating with a neural network specialist, military communications experts developing breakthrough scientific protocols. Their strength was not in individual brilliance. It was in their ability to create something greater than the sum of their parts. Outside the research centers and diplomatic halls, most of humanity remained unaware of the profound impact they had made. Workers continued their daily lives. Students attended classes. Politicians argued about local issues, completely unaware that they had fundamentally transformed the galactic understanding of intelligence, cooperation, and potential. Krelok's final annotation to the historical document captured the essence of humanity's journey. They did not conquer. They did not destroy. They transformed. The Galactic Archives would forever mark this period as the human paradigm shift, a moment when a species was not just discovered, but when the very understanding of discovery was reimagined. Humanity had done more than explore the galaxy. They had expanded the very concept of what was possible.